Space, the home of trillions of stars and planets, so endlessly vast that our greatest scientists have only begun to understand its splendor. Yet, nestled within the cosmos, a near-death star draws eyes from all across our universe. Its death will have a profound outcome and a life-changing effect. A supernova, exploding with enough force to send the very foundations of life speeding through our universe. Things like carbon, oxygen, and of course, some very bright light travel across space. On Earth, a death like this draws the attention of scientists like Douglas Leonard, astrophysicist and San Diego State professor.
My name is Douglas Leonard. I'm a professor of astronomy here at San Diego State University. It's kind of amazing, but I can honestly say that if it weren't for supernovas, we wouldn't be here today. They are fundamental to life as we know it in the universe, because our universe wasn't really born with the raw materials that make human beings or really any kind of life that we have today. So it's completely necessary that a fraction of stars just explode all their material out into space, because it's all that heavier element material, iron and oxygen and carbon, that litters the universe and that ultimately produces things like Earth and things like life on Earth. Okay, so a star is a ball of gas, mainly hydrogen with some helium, simplest elements. And if enough gas is drawn together by the force of gravity, then the pressure and temperature in the core of that ball of gas gets hot enough for nuclear fusion to begin.
As lightweight particles like hydrogen collide, the process of nuclear fusion generates waves of energy that power the star.
Of course, it's using up its fuel supply. It's like a car that filled the tank of gas and it's just driving along. It's using up the gas, and at some point, it's going to run out of the fuel that it has for nuclear fusion.
As gravity pulls the star together, the force created by nuclear fusion repels outwards against it. With age, the star's repelling force diminishes, and gravity begins to overpower it, collapsing the star upon itself.
For most stars, it's a pretty gentle process. It kind of contracts a little. When it contracts, it heats up. That makes more nuclear fusion, and more fuel runs out, it contracts some more. It's kind of a gentle process that happens over billions of years. For a rare subset of stars, though, when the fuel runs out, it happens in a very dramatic manner.
Now a fraction of the size it once was, this rare, highly pressurized star reaches its critical mass and completely explodes.
A big misconception about supernovas is that we actually understand them. Nature teases us because somewhere in the observable universe, one star every second is exploding. So nature knows how to explode stars. The trick is that astronomers have not figured out how she does it yet. Fundamentally, when we put in all the conditions that we think exist during that final stellar collapse, and we put all that into our computers with our best modeling and our best understanding of how physics works, and we ask the computer what happens next, the thing never explodes on the computer. That's not the outcome.
Despite supernova discoveries within the thousands thus far, because of their sheer distance from Earth, our scientists have little to work with when researching them, apart from a speck of light in the sky.
We wish that the signs were that we look up in the sky and just see a star exploding. They're just so far away that even though with the explosion and they eject things at 20,000 kilometers per second, the material's spreading out into space, even though our best instruments today is just a dot in the sky.
With the evidence they have, it's a miracle that scientists like Professor Leonard and his students have discovered what they have. Often in a case like this, we're left with more questions than answers. Which stars will come to an explosive end?
trying to answer that question is kind of like doing forensics. It's kind of like working back in time.
When a star explodes, it gets everyone's attention. But if we're lucky enough, someone will have captured a photo of the star before and after its demise. With these two images, our scientists will be able to compare the star with its supernova.
I'd say a misconception about supernovas is this idea that every star explodes at the end of its life, or even that our sun's going to do it. Best we can tell, it's a pretty rare star that ends its life this way. There have to be a bunch of characteristics that the star has in order to end its life in such a dramatic fashion. As far as we know, our sun is one of the boring 99.5% of the stars that will die, meaning it will eventually fizzle out and no longer create its own light and energy. But it's not going to pass into that death in so dramatic a fashion as a supernova does by exploding. It's a very kind of peculiar kind of star that does that. And our sun is basically a generic run-of-the-mill average star. And it will die, but as far as we can tell, it's not going to die by exploding.
It's important for us to remember that all life throughout our universe evolves in cycles. Much like our lives on Earth, the stars in our universe will continue to constantly be born, and all will eventually die. For us, there is little to do. We must continue our lives as we always have. But when we look into the night, we must remember that the cycle of life creates just as much as it destroys.